Trigonometry, 2011, January 2011, question 34. Assume that the ages of first-year college students are normally distributed with a mean of 19 years. That means the normal is about, the average is about 19 years old, with a standard deviation of 1 year. That means the standard deviation of 1 is standard deviation of 1 year. To the nearest integer, find the percentage of first-year college students who are between the ages of 18 and 20 years inclusive. That means 18 means not only 19 years old. Instead of between 18 and 20, we mean not only 19, we mean 18 also and 20. 18, they're between ages 18 years and 20 years inclusive, including all of that, including years 18, years 19, years 20. Question 34. Assume that the ages of first-year college students are normally distributed with a mean of 19 years and a standard deviation of 1 year. That means in the middle will be 19 years old. That's the mean over here, 19. And the standard deviation is 1 year. That means if you go over one standard deviation, you'll hit 1 year. That means we know that this graph over here, because we're speaking about it's normally distributed, means it's distributed in this type of graph. And if you look on your sheet that you're given with the regions, with all the formulas, you have a normal curve of standard deviation. So whenever it says normally distributed with a standard deviation, we're speaking usually about this type of curve, this type of mountain. Now, if you know that, if you look at it, you'll see that it shows you 19.1% on one side of this long line and 19.1% on the other side. So that means that altogether, if you add up everything, you'll see it equals to 100%, meaning 100% of what we're speaking about. And so from -1, 0 is the mean. That's between 3 standard deviants of each side, from 3 to -3. So the mean is 19 years old. And one standard deviation, we set a standard deviation, that means one standard deviation of 1 year, meaning 1 year. So if you go over here, make a line up here, so this will be 19, and then this over here will be, let's say to the right, would be 20 years old, and to the left, to the negative, would be 18 years old. So over here you have 18, 19, and 20. So the question is, first part of question 34, to the nearest integer, find the percentage of first-year college students who are between the ages of 18 years and 20 years inclusive. So let's add this up. 15 plus 15 is equal to 30. And 19 plus 19, if it's hard for you, just make it 20 plus 20, which would be 40. 40 and 30 would give you 70. However, you take away the 2 that you added, and it will give you a 68. Now add the 2 point ones, so it's 68.2. Or you could just have added it up, 15 plus 19.1 plus 19.1 plus 15, which is equal to 68.2. And the question is, to the nearest integer. Integer is a whole number, as you learned in Algebra 1. A whole number, if you have 68.2, and to the nearest number, since it's 0.2, 4 and down, you round down, so it's 68. And the answer is 68% of the students are within one standard deviation. So the question is, to the nearest integer, find the percentage of first-year college students who are between ages 18 years and 20 years inclusive. The answer is 68%. If you want to write the whole thing out, you could write 68% of the students are within one standard deviation of the mean. But if you would write 68%, that should also be right. The reason why they don't ask you to make this graph or to show a lot of work is because all the work is done on the formulas that they give you with the test, with this type of curve. Part 2 of question 34. To the nearest integer, find the percentage of first-year college students who are 20 years old or older. Well, we said the middle is 19, one standard deviation, meaning going to, it's not over here, one standard deviation is 0 to 1, or 0 to -1. So 0 to 1 gives you till age 20. Now we want find the percentage of first-year college students who are 20 years or older. So after this starts at 1 starts 20 years old, because this is 19. Down at one standard deviation becomes 18 into the negative. At one standard deviation to the positive becomes 20. Beyond 20 will give you the amount, the percentage of first-year college students who are 20 years old. So you have 68.1%. It was 68.2% was the amount in the middle. Within one standard deviation is always 68%. So you put on your calculator and you put in the 68.2 and you subtract 100 from it, you'll get 31.8. That means to the left, beyond -1%, beyond -1 standard deviation, and beyond to the right, 1 standard deviation, you have 31.8%. So the question is, what is half of that? Because we don't want younger than 18, all we want is 20 and older. So you do 31.8 divided by 2, which is equal to 15.9, but rounded to the nearest number, the nearest whole number. The 15.9% rounded to the nearest whole number is 16%. Question 35. Starting with sine square of A plus cosine square of A is equal to 1, derive the formula tangent square of A plus 1 equals secant square of A. Well, the way to do this is, you have sine of square of A plus cosine square of A is equal to 1. So we're going to erase what we want to derive, and we're going to work on this. Let's divide everything by cosine square of A. This way we'll get rid of one of them, and when you have sine over cosine, that will just become tangent. The sine over cosine is equal to tangent. So therefore, that's why we're not dividing everything by the sine. So, because we're trying to get the formula of tangent square of A plus 1 equals secant square of A. So divide everything by cosine square of A, sine square of A divided by cosine square of A plus cosine square of A divided by cosine square of A is equal to 1. But whatever you do to one side of the equation, to keep it equal, you have to do to the other side. So it's equal to 1 over cosine square of A. Let's move down here. Now, cosine square of A over cosine square of A is just 1. Sine square of A over cosine square of A is equal to, sine over cosine is tangent, so it doesn't make a difference. If they're both to the same power, you just take the square root of each one. And tangent, you could square it, will become tangent square of A. So sine square of A over cosine square of A is equal to tangent square of A plus 1 equals 1 over cosine square of A. Well, how do you find the secant? The secant is 1 divided by the cosine. So 1 over cosine square of A is equal to secant square of A. That's over here. Tangent square of a plus 1 is equal to secant square of a. So the question is, if everything's here, what did you add? The answer is you added that you divided the first formula by cosine square of a. And over here, you got, it was originally sine square of a plus cosine square of a is equal to 1. You divided everything by cosine square of a. So the cosine square of a over cosine square of a became 1, which we wanted. The sine square of a over cosine square of a became tangent square of a, which we got over here. And 1 divided by cosine is the same thing as secant. So 1 over cosine square of a is equal to secant square of a. So this is your final answer. But you have to show this work. You have to write sine square of a plus cosine square of a is equal to 1. Divide each thing by cosine square of a. And sine square of a over cosine square of a is equal to tangent square of a. Cosine square of a divided by itself is equal to 1. And 1 over cosine, or 1 over cosine square of a, is equal to secant square of a. So it's not that difficult. If you do this problem 2-3 times, you go through 2-3 regions, there's no reason you should get a question like this wrong. Question 36. Write the binomial expansion of 2x minus 1 to the fifth power as a polynomial in simplest form. Again, write the binomial expansion of 2x minus 1 to the fifth power. That means that 2x minus 1 is raised, that whole thing is raised to the fifth power. Write it as a polynomial in simplest form. As a binomial expansion. Let me first show you what they do not want you to do, which will come to the same answer, but you will use this answer afterwards to check your work. The reason why I'm doing it now is because I want to end on the board with the correct answer, with the correct work. So first let's do it the old-fashioned way, which is not what they're asking you for. 2x minus 1 to the fifth power is the same thing as 2x minus 1 times 2x minus 1. Remember, this is not a binomial expansion. This is the old way that we used to do. 2x minus 1 times 2x minus 1 times 2x minus 1 times 2x minus 1. So that's 1 time, 2 times, 3 times, 4 times, and one more time, times 2x minus 1. And if you work this all out, you'll see, first we're going to take the first two, and we're going to do FOIL. First, outer, inner, last. 2x times 2x is 4x squared. Outer, 2x times negative 1 is negative 2x. Inner, negative 1 times 2x is negative 2x. And last, negative 1 times negative 1 is plus 1. So now that we're finished with these two, we're going to do this whole thing times the third one. So we're going to move it down here. 4x squared, and negative 2x minus 2x is negative 4x, and it's plus 1. Now this whole thing, when you bring this down, it's times the third 2x minus 1. Remember, this is not what they're asking you to do. I'm just showing you that you could check your work to see if you came to the right answer in the binomial expansion by seeing if it works out this way. And it will. If it doesn't, then you know you got the wrong answer in the binomial expansion. As soon as we finish this, we'll do the correct one of the binomial expansion. Now, you do FOIL again. You distribute 2x times 4x squared is equal to 2 times 4 is 8. X squared times x is x to the third power. Then 2x, a negative 4x times 2x is negative 8x squared. We write it on the next part of the board. So it's minus 8x squared. Then 2x minus 2x times 1 is plus 2x. Then you have to do the same thing with the 1. 1 times the 4x squared, then 1 times the 4x, and then 1 times 1. So 1, it's a negative 1. Negative 1 times 4x squared. I'm going to write it on top. I'm going to add these together. Negative 1 times 4x squared is negative 4x squared. Then negative 1 times negative 4x, a negative times a negative is a positive. Negative 1 times a negative makes a positive 4x. So it's plus 4x. And negative 1 times 1 is equal to negative 1. We're going to start erasing in order to make room for these answers. So we got rid of the first three. And we got rid of this. And get rid of this now. And remember, this is 2x minus 1 to the 5th power. We're going to just move it out of the way for now. We're going to move this all up here. So it's 8x to the 3rd power. You have over here 8x to the 3rd power. And negative 4x squared plus 8x squared. So you owe 4x squares and you owe another 8x squares. So you owe 12x squares. And 4x plus 2x is 6x plus 6x. And it's minus 1. That whole thing, you take the next one, the 4th 2x minus 1, and you move it over here. Because you have to multiply it 5 times. So far we only multiplied 2x times 2x minus 1 multiplied by itself 3 times. This is the 4th time. So now that we get rid of it, we move everything out of the way. We just have the 5th one we're going to use soon. So it's 8x cubed minus 12x squared plus 6x minus 1. So we can move all this out of the way to make room. And the reason why I keep on erasing is because, first of all, there's not enough room. Second of all, this is not the answer they're asking you to give. If you give this answer, you're not going to get it right. This is only to check your work for yourself on a separate page, not on the page itself where you're supposed to put in the answer. So, 2x times 8x cubed. So 2 times 8 is 16. X times x to the 3rd power is x to the 4th power. Then 2 times 12 is 2 times a negative 12. 2 times negative 12 is negative 24. And it's x squared times x is x to the 3rd power. Then 2 times 6, it's a positive, is 12. X times x is x squared. And 2 times negative 1 is negative 2, but it's negative 2x. Fine, that's for the 2x. Now you have to use the negative 1. So now it's negative 1 times 8x cubed is negative 8x cubed. As you notice, I put like terms. I put we owe 24x cubes and we owe another 8x cubes. That's why you put the ones on top of each other, just like you did in 1st grade. The ones on top of the ones, the 10s on top of the 10s. Then, so that's negative 1 times 8x cubed. Then negative 1 times a negative becomes a positive 12x squared. And then plus negative 1 times a positive becomes a negative 6x. And negative 1 times negative 1 is positive 1. Now we have to add this all up. We add this all up, we get 16x to the 4th power and minus 24 and 8 is 32. You have 32x cubes, and positive 12 and positive 12 is positive 24. X squares, and negative 2x and negative 6x is negative 8x, and 1 and 1, 0 plus 1 is 1. So now we're ready to bring down the final 2x minus 1. So now we're going to erase everything over here. At any point over here in this question, you're going to have to press pause. A lot of times on the video recorder, on your DVD or computer, in order to see how I'm doing this, and write this out with pen and pencil in order for it to work. Now we're up to the last 2x minus 1 times the last 2x minus 1. Fine. For this we'll need the most room. I'm going to do it up here so we don't get confused. So, the first 2x times 16, 2 times 16 is 32, times x, and x to the 4th power. See that again. 2x times 16 is 32. X times x to the 4th power is x to the 5th power. Next, 2 times negative 32 is negative 64. X times x to the 3rd power is x to the 4th power. Then plus 2 times 24 is 48. X, I'm going to put it over here so you see it's one thing. So it's plus, again, 2 times 24 is 48. X to the 2nd power times x is x to the 3rd power. You see, even as a teacher, I can make a lot of mistakes, so it's very important to do this very slowly. Again, 2 times 24 is 48. X squared times another x is x to the 3rd power. And over here, I think I did my first mistake. One of my mistakes, which is I didn't put in the x. So negative 8x times 2x, so it's minus 2 times 8 is 16. And x times x is x squared. Then 2x times 1 is just plus 2x. Now, when we're finished with the 2x, we're going to move out of the way. We're just going to multiply everything by negative 1. Because we already did the 2x. So, we're just multiplying everything by negative 1. So now, negative 1, it's x to the 4th power. So we put the x to the 4th power over here. And it's 16 times negative 1 is negative 16. Then negative 32 becomes a positive 32 because it's multiplied by negative 1. X to the 3rd power. Then positive 24 becomes a negative 24 because it's multiplied by a negative. An odd amount of negatives gives you a negative. Negative times 1 negative times 1 positive is a negative. So it's negative 24 x squared. And negative 1 times negative is a positive 8x. Then negative 1 times 1 is negative 1. Finally, when you finish with all that, we're going to add it up. And when you finally finish with this, leave this in a separate piece of paper. Remember, none of this, you should be doing none of this on the real exam paper. You should do this on a piece of scrap paper because this is just something you can check your work with. And if you check your work with this, because a question like this, you have enough room to check your work, and you check your work like this, the teacher might think, or may come to think, or may want to think, that this answer is what you gave, and this is not what they call a binomial expansion. So let's add this up and see if, and hold on to it for later to see if this will be the final answer we're coming out with at the end. So you have 32. See how numbers disappear? I wrote 3x. It's 32 x to the 5th power, and 64 and 16 is 80. It's negative 80 because it's negative 64 and negative 16 is negative 80. And you have 64x to the 4th and another 16x to the 4th. So you have 80x to the 4th plus 32 plus 48 is another 80. And you have 80x cubes. That means x to the 3rd power. And 16 and 24, negative 16 and negative 24 is negative 40. And you owe 16x cubes, you owe another 24x cubes. I mean you owe 16x squares and you owe another 24x squares, so you owe 40x squares. And then plus 10x, 4 plus 2x plus 4x, 2x plus 8x. 2x plus 8x is 10x. And then just minus 1. Remember this. This should be the answer. I will check it myself to make sure. It should be 32 Write this down because we're going to erase everything now and do it the correct way. This is not the correct way. This is just in order for you to check your work and see if you got it with the correct answer with using your calculator with all different types of combinations. So the correct answer, which they would give you partial credit for this if you showed this way, but you should not show this way, you should show it as a binomial expansion. So the correct answer, which we'll see soon why it's correct when we do it the correct way, in the binomial expansion, should be 32x to the 5th minus 80x to the 4th plus 80x to the 3rd minus 40x to the 2nd power plus 10x minus 1. Now let's erase all of that, and now we're going to do it the correct way. So don't forget this.